Good morning, students. So, good morning, all of you. So, in the previous class, give the description about the channels. You know, the channel is the most important block in the communications. So, because of most of the noise added in the channel only. So, the noise contaminates the information. So, there is a quality of the signal has to be deteriorated. Quality of the signal has to be deteriorated because of the noise. Okay. Now, in that noise elimination process, you need to know that what is the perspective density of the noise, how far it is added to the signal. So that is the parameter to calibrate, that is signal to noise ratio. How much noise is contaminated with information. Whereas in the analog domain, the signal perspective density and noise perspective density are merged. If the noise perspective density is more than the signal perspective density, then the signal is contaminated. So already, you know, the Y is the output of the channel, X is the input of the channel. Then Y is equal to X plus N is the expression there. Y is equal to X plus N. So where Y is an output, X is input, and the parameter added N is the noise. If the Y is equal to X, Y is equal to X, when the noise is 0. So in the practical case, N not equal to 0, that's why you have to prefer some calibrations to know the how much noise is added in the signal. So it's a very interesting topic in the communications. So that's why you have to go by the channel now. Today you have to more analytical view on the channels. So you know the channel is the discrete memory channel. The previous classes always you prefer discrete memory source. The source emit the signals. If it is the discrete data has to be emitted from the source. Discrete data, that is a separate samples are emitted by the source. Likewise, in the discrete memoryless channel, the signals are passed through a channel, and the channel should be the memoryless. Let us channel representation. A channel is a statistical model. A channel is a statistical model with an input X and output Y. A channel is a statistical model with an input X and output Y. The channel is said to be discrete. The channel is said to be discrete when the alpha bits of the X and Y are both are finite. So there is a finite of the data. Data should be the finite, not infinite. Data should be a finite. The type of channel known as a discrete channel. So like a finite signal is there, or finite symbol is there. If the symbols are there, there always should be a finite in the form. Alphabets are all alphabets are the finite. So that's why the symbols are considered as the discrete. So like in this X and Y variables are taken here. So both are the finite, then those are the discrete. So X is the finite value and Y also the finite value. So we may call that the discrete. So also it is said to be memoryless. When the current output depends on only the current input and not only any previous inputs. So that is X1 and Y1, that to be an example. Y1 should be depending upon X1 only, not X2 and X3. So that's why it is said to be memoryless when the current output depends on the current input and not any of the previous inputs. So that is the case in the discrete and memoryless channels. Discrete and memoryless. The discrete means that signals should be a finite value, and the memoryless means the current output depends upon current input only, not the previous values. So the current input depends on current output related to current input. So that is the memoryless. There is no memory. That's why, but the storage capability not there. So that's why a channel is discrete memoryless channel. Now, so it is the model, the channel model. There is a channel, X is input and Y is an output. X is input and Y is an output. So where the P of Y by X, P of Y by X, there is Y of J and X of Y. So where X is the number of inputs are there and Y is number of outputs are there. So the transition is P of Y by X, P of Yj by Xi. Here it is in the case. So please students, so please see that the model of the channel. It is the channel model. If the X is the input of the channel, then X1, X2, X3 up to X of M are the variables. Up to M variables are there belonging to X. X is the input. And the like Y is and variables Y1, Y2, Y3 and Y of N. So M number of inputs are there, N number of outputs are taking place. M number of inputs are there, N number of outputs are taking place. So X1, X2, X3, X of M inputs are given. So that is X. And Y1, Y2, Y3 up to Y of N, that is Y. That's why, so the X is input and Y is an output. There is a transition condition or P of Y by X is nothing but conditional probability. The condition has to be imposed here. If X is the input, Y is an output. If X1 is the input, Y1 is an output. If X2 is the input, Y2 is an output. Likewise, a condition imposed there. P of Y by X is the conditional probability. So the conditional probability P of Y by X also known as a channel transition probability. So the channel transition probability is nothing but P of Y by X. That is, so X input and Y outputs. So X is the number of variables are taking place and Y are the number of variables are there. How many number of inputs are there? Same number of outputs are taking place. So that is a conditional probability case. So this is the channel model. Now, in this channel model, P of Y by X, a conditional probability or channel transition probability is a very important parameter here. So depending upon that parameter, can classify the channels. P of Y by X is the conditional probability or channel transition probability. So you can arrange the elements in the matrix, that is channel transition matrix. So the channel transition matrix is a channel is specified by the set of transition probabilities. So the probabilities are a conditional probability. It should be a conditional probability. A condition is imposed there. Okay. So that is X inputs and Y outputs. So number of X are there, number of Y's are there. So X and Y are equal set. Then P of Y by X is the channel transition matrix. Channel transition probability is converted to channel transition matrix. So the matrix, the number of elements are there. Those elements are probability elements, transition probability elements. So let us say in this matrix, rows and columns are there. The rows are having some specific values, and columns are also some specific values. So P of Y1 by X1, the first element. P of Y1 by X1, the first element. P of Y2 by X1, second element. P of Y3 by X1, third element. So on, P of Yn by X1. What is the first row says? X1 is the only input. Y1 is the output. Y2 is an output. Y3 is an output. Up to Yn are the output. Because of Yn is the n number of outputs are taking place. So only here it is the first row reflects only X1 input. X1 input, Y1 output, the first element, X1 input, Y2 output, the second element, X1 input, Y3 output is the third element. So on up to X1 input, Yn output. X1 input, Yn output. That is the first row. The second row itself says X1 out, X2 input, Y1 output. X2 input, Y2 output. X2 input, Y3 output. The second row first element is Y1 by X2. That means X2 input, Y1 output. Y2 by X2. X2 input, Y2 output. Y3 by X3. Y3 by X2. X2 input, Y3 output. That is, second row says X2 is the input everywhere. Then the output is Y1, Y2, Y3 up to Y of n. Up to Y of n. So, like students, you have to know that third row. What is the third row? P of Y1 by X3. Okay, P of Y2 by X3. P of Y3 by X3. So on. Like that up to P of Y1 by Xn, last row. P of Y1 by Xn, P of Y2 by Xn, P of Y3 by Xn, up to P of Yn by Xn. So this is the matrix. The matrix first row and first column says Y1, Y2, Y3, Y4 are the outputs of the first row where X1 is input. The first column, Y1 is an output and X1, X2, X3, X4 up to Xm are the inputs. Xm are the inputs. So this is the case of set a channel transition matrix. Set a channel transition matrix. So this channel transition matrix is very important while you are classify the number of channels. So here it is. While you are set the channel matrix, the diagonal element should be, what are the diagonal elements? Y1 by X1, Y2 by X2, Y3 by X3, Y4 by X4, like those are the diagonal elements. Is it not? Yes. Now, row of the channel matrix is unity. Row of the channel matrix. It should be unity. That is, P of Yj by Xi should be the 1. Sigma P of Yj by Xi is the 1. So that is all the elements in the first row equated to 1. All the elements in the first row should be equal to 1. That is adding of all the elements in the first row that equal to 1. That is unity. So that is the any row, first row or row of the matrix. Row of the matrix of the channel matrix. The first row, second row, third row, fourth row. If it is any row, the row addition, the row addition should be the unity. Should be the unity. Okay. So input and output probabilities are represented by row matrix. Whereas the channel matrix is, that is, the channel matrix is arranged. That is, the rows and columns are there. Like input and output probabilities also represented in the matrix form. Now we can only the representation process here. First representation is channel matrix. First representation is channel matrix. That is rows and columns. The first input, what is the input of the channel? X. X also a matrix. X also a matrix. X contains the number of inputs, no? X1, X2 up to X of n. So X is the input, and then the X elements are represented in the matrix, that is the row matrix. X element in the represented in the matrix, that is the row matrix. Like the Y elements also represented in the matrix, that is the row matrix. So input and output should be the representation of the row matrices. Input and output should be the representation of the row matrices, like the channel matrix. So the input matrix is P of X, that is P of X1, P of X2, P of X3, up to P of Xm. That is Xm are the elements now. That is X1 to X2, X3, up to X of M. Like outputs, P of Y is equal to P of Y1, P of Y2, P of Y3, up to P of Yn. So now you can represent a channel matrix and input matrix and output matrix. Channel matrix is a matrix of a number of elements are there, row and columns are there, and input matrix is row matrix, output matrix also the row matrix. Now, the output matrix probabilities are related by, there is a formula, output matrix. So always can calculate the output of the channel now. That is P of phi. P of phi. P of phi is an output. So see this formula it is. P of phi is equal to P of phi in output of the channel is equal to P of x. That is input of the channel. P of x input of the channel multiplied by P of y by x. What is the P of y by x? Channel transition matrix. So now the P of y is equal to P of x into P of y by x. So students, please be note that this is an important formula. That is output of the matrix, output of the channel. Sorry, output of the channel is equal to P of x input and channel matrix. P of y is equal to P of x into P of y by x. P of y is equal to P of x into P of y by x. Okay, this is the output of the output of the channel, the P of I, P of I in output. So P of I should be the row matrix. Now, and another parameter is joint probability representation. The previous one is output probability are represented. Output probabilities are represented P of I, whereas joint probability is represented by, what is the joint probability? Joint probability is nothing but P of x comma y. P of x comma y. P of x comma y is the joint probability. It can be calculated. It can be calculated with P of x the d, P of x the suffix d no. That means P of x in the form of the diagonal arrangement. P of x in the form of diagonal arrangement. P of x in the form of diagonal arrangement. P of x in the form of diagonal arrangement. P of y by x is channel matrix. So P of x is the diagonal and P of y by x is the channel matrix. Okay. So now the joint probability is represented by P of x comma y, where the P of I is output of the matrix. P of x comma y is the joint probability. P of I is output probability. P of x comma y is joint probability. That can be represented as P of x in the diagonal arrangement multiplied with P of y by x. P of y by x. So no, you know that P of y by x is the channel matrix, where P of x of d is the input symbols are in the arranged in the diagonal matrix. The diagonal form. What is the diagonal form? P of x d is equal to P of x1. All the diagonal there is x1, x2, x3 up to x of f. All the diagonal. The remaining elements should be the zeros. Likewise, you can arrange the input matrix in the form of the diagonal. Input elements are in the form of the diagonal arrangement. Input elements in the form of diagonal elements. If suppose input are 3 elements, how can you arrange the diagonal? How can you arrange the diagonal? How can you arrange the diagonal? Huh? That is the form of square matrix itself. So depending upon the 3 into 3 matrix, because of the if x is equal to 3 now, 3 into 3 matrix. In the 3 into 3 matrix, on the diagonal, x1, x2, x3 are there, and the remaining all zeros. Remaining all zeros. Likewise, you can arrange the x of d. For that, the diagonal arrangement of the input matrix. Input matrix is P of x. So multiplied with P of y by x. Multiplied with P of y by x. Now, so that is here can the two important parameters to represent here. That is output of the channel in the form of the matrix, that is P of y, and joint probability in the form of matrix P of x comma y. So wherever you need to know the output, should be calculated P of y. That is P of y is equal to P of x into P of y by x. If you need joint probability, P of x comma y is equal to P of x in the form of the diagonal into P of x comma P of y by x. So that means output is equal to input into channel matrix, and joint probability is equal to input in the form of diagonal into channel matrix. So that is both the case channel matrix is multiplied. Okay, the channel matrix is multiplied with input matrix. That is the output is no. The channel matrix is multiplied with the diagonal arrangement of the input matrix. That is the joint probability is no. So that is the case of the parameters in the discrete memory channels. Now, then you go for another concept. It is types of channels. Types of channels. So channel types are classified according to the channel transition matrix. Channel types are classified according to the channel transition matrix. Okay. So there are 4 types of the channels. One of the channel is lossless channel. Lossless channel. Another one is deterministic channel. Deterministic channel. The third one is noiseless channel. Noiseless channel. The fourth one is binary symmetric channel. Binary symmetric channel. Okay. So students, these are the 4 important types of the channels. Okay. So in the broad classification of the channels are AWGN channel is there, one of the channel, and relay fading channel is there, another channel. Okay. The AWGN channel means additive white Gaussian noise channel. Channel is additive white Gaussian noise channel. So what it means, the noise is added to the signal. The noise perspective density should be the Gaussian distribution curve. The noise should be the white noise. Okay, that is the AWGN channel meaning. Additive white Gaussian noise channel. The noise added to the signal, the noise should be the white noise. It should be Gaussian distribution curve as the perspective density. So that is the meaning of the AWGN channel. So in that channel, there is a subclassification is lossless channel, deterministic channel, noiseless channel, and binary symmetric channel. In the AWGN channel, so the noise should be the white noise, no? The noise should be the white noise. So white noise means the perspective density of the noise is the uniform entire the frequency range. Whatever the frequency range you can take in, the entire the range, frequency range, noise perspective density should be the unity. Noise perspective density should be the unity. That is the case of the AWGN channel. So if the noise perspective density is unity, that is noise perspective density is uniform, not the unity. If the noise perspective density is uniform, that is the white noise. Noise perspective density is uniform, that is the white noise. So noise perspective density is not uniform. That is known as a pink noise. That is known as a pink noise. So now this types of channels: lossless channel, deterministic channel, and noiseless channel, binary symmetric channel. Please note down the type of channels. One is lossless channel, deterministic channel, noiseless channel, and binary symmetric channel. So the channel classification depends on channel transition matrix. Channel classification depends on channel transition matrix. Okay. Now, let us see the first channel. What is that? Lossless channel. Lossless channel. What is the basic origin of classification of the channels? Channel transition matrix. Depending upon the channel transition matrix, can classify the channels. Can classify the channels. So lossless channel is the channel. It is defined as in channel transition matrix. In channel transition matrix, only one non-zero element is in the each column. One non-zero element in each column. So in a lossless channel, no source information is lost in transmission. In transmission, no channel information is lost. That is, as it is, what are the information is given in the input, the same information is received at the receiver. There is no loss in the channel, in the middle of the channel path. In the path, there is no loss. So that is known as lossless channel. Please note on the definition of lossless channel. Lossless channel is defined as in channel transition matrix, only one non-zero element in channel transition matrix, channel transition matrix, only one non-zero element in each column. One non-zero element in each column. Okay, in the column, only one non-zero element. The remaining elements are zeros. Only one non-zero element in each column. In lossless channel, no source information is lost. The transmission, no signal is lost. That is the lossless channel. There is no loss in the channel path. That is the lossless channel. So what are the condition? The channel transition matrix rows and columns are there, no? The channel transition matrix rows and columns are there, no? In each column, please be note the lossless channel property. In each column, one non-zero element is there. In each column, one non-zero element is there, and the remaining elements are zeros. That is the specification of the lossless channel. What is the lossless channel? In the channel transition matrix, in the column, one non-zero element is there, the remaining elements are zeros. In column, only one element should be there. That element is a non-zero element. The remaining elements are zeros. Okay, let's take an example. It is P of y by x is equal. It is example. P of y by x is equal. First column is how many? The first column 3 elements are there. First element is 3 by 4. Second element is 0. Third element is 0. The second column 1 by 4. The remaining elements are zeros. The third column 0, 1 by 3, 0. The fourth column 0, 2 by 3, 0. The fifth column 0, 0, 1. It is, that means in a column one non-zero element is there. The remaining elements are zeros. And are you observe this? The row elements should be the unity. Add all the row elements should be the unity. What is the first row? 3 by 4 plus 1 by 4. What is the value? 1. The second row is 1 by 3 plus 2 by 3. What is the value? Unity. The third row? 1. So that means row sum should be the unity, and row sum should be the unity, and one non-zero element in each column. Please be note that condition, the last channel. So in each column, one non-zero element is there, and the row sum should be the unity. The row sum should be the unity is always it is the unique principle in the channel matrix. Unique principle in the channel matrix. So the first row, all the elements should be equal to 1. Second row, all the elements should be equal to 1. So likewise, okay. In this last channel, one non-zero element in each column. One non-zero element in each column. Okay. So if it is the case, P of y by x is equal to 3 by 4, 0, 0, 1 by 4, 0, 0, 0, 1 by 3, 0, 0, 2 by 3, 0, 0, 0, 1. So let us find that output P of I. Let's find out P of I. P of I is equal to P of x into P of I by x. What is P of x? P of x is the input. P of I by x is the channel matrix. Channel matrix is given here. Channel matrix is given here. So the P of x is the input. Okay, P of y by x is channel matrix. Now the P of y is P of x into P of y by x. So if suppose there are 3 elements are there, x1, x2, x3. So the P of x is equal to, here the P of x is equal to, P of x is equal to x1, x2, x3 multiplied with P of y by x is the 3 by 4, 1 by 4, 0, 0, 0, 0, 0, 0, 0, 0, 1 by 3, 2 by 3, 0, 0, 0, 0, 0, 1. Okay, the channel matrix. That is x1, x2, x3 multiplied with the channel matrix. 3 by 4, 0, 0, 1 by 4, 0, 0, 0, 1 by 3, 0, likewise. No? So now x1, x2, x3 multiplied with channel matrix. Now the P of y1 is equal to P of y1 is equal to x1 into 3 by 4, x1 into 3 by 4 plus x2 into 0 plus y3 into 0. Then what is the value? P of y1 is equal to 3 by 4 into x1. That's the P of y1. Next, P of y2 is equal to x1 into 1 by 4, x2 into 0, x3 into 0. Simply matrix multiplication takes place here. Two matrices are multiplied. One of the matrix is the row matrix, and the matrix is the column, and matrix channel matrix. The row matrix is the input matrix. That is x1, x2, x3. Channel transition matrix is these are the elements. So P of y1 is equal to 3 by 4 into x1. P of y2 is equal to 1 by 3, 1 by 4 into x1.
వాటర్ పని చేయదు
And P of y3 is equal to
లేదు బాబు, వైర్ పీక్ సార్ చూడు అక్కడే ఉంటది కాలట్లే. తాగుతావా? తేలేదు మేము వాటర్ కూడా ఉన్నా. మోటార్ అది చూడు, దానికి వైర్ లేదు, ఇక్కడి నుంచి కనెక్షన్ చూసి వాళ్ళు అక్కడ చూడు, ఇంటికి వెళ్ళిపోతే తాగిడమే. మేము కూడా తాగడానికి తేలే.
no? Okay. Simply it is a matrix multiplication. P of y3 is equal to P of y3 is equal to x1 into 0, that is 0, plus x2 into 1 by 3 plus x3 into 0, that is 0. That is P of y3 is equal to 2 by 3 into x2, and P of y4 is equal to 1 by 3 into x2. So here it is, there is some P of y2, P of y3 is equal to 1 by 3 into x2. P of y4 is equal to 2 by 3 into x2. Okay, this is y3, y4, y3, y4. Y3 is 1 by 3 into x2. Y4 is 2 by 3 into x2. And P of y5 is equal to 1 into x3. 1 into x3. So that is how many output elements are there? That depends upon number of columns. That is matrix multiplication is known. The matrix multiplication is says row multiplied with column. So how many columns are there in the channel matrix? Those number of outputs are considered. That is P of y1, P of y2, y3, y4, and y5. Now P of y1 is equal to 3 by 4 into 1. P of y2 is equal to 1 by 4 into 1. P of y3 is equal to 1 by 3 into x2. P of y4 is equal to 2 by 3 into x2. P of y5 is equal to x3. P of y5 is equal to x3. Now P of y1, y2, y3, y4 are there. So let us draw the matrix diagram. So there is inputs and outputs are there. How many inputs are there? There are 3 inputs: x1, x2, x3. X1, x2, x3 inputs are there. Outputs are y1, y2, and y3, and y4, y5. y1, y2, y3, and y4, y5. So simply, what is this? 1, 2, 3, 4, 5. 5 only, not the 6, 5 only. Okay. Now what is P of y1? P of y1 is equal to 3 by 4 into x1. That is x1 is there. That is the connection between x1 to x1, y1, or the magnitude 3 by 4. Like y2 and x1 relation. Y2 and x1 relation. Y2 is equal to 1 by 4 into x1. 1 by 4 into x1. So like y3 is equal to 1 by 3 into x2. and y4 is equal to 2 by 3 into x2. Y5 is equal to 1 into x1, 1 into x3. So you can draw the channel diagram by using these formulas. P of y1, y2, y3, y4, and y5. Okay. So now, so it is the case of the channel diagram. And uh, second channel is deterministic channel. The deterministic channel, please note down. Deterministic channel is defined as the channel transfer matrix. The channel transfer matrix. Only one non-zero element in each row. Only one non-zero element in each row. The remaining elements are zero. Is it not? Only one non-zero element in each row, and the row sum should be unity. The row sum should be unity. This is the generalized form, generalized condition. Row sum should be the unity. In deterministic channel, a given source symbol is determined at the receiving end. Given symbol input is determined at the receiving end, at the output. Okay. So now, in this, one non-zero element in each row. One non-zero element in each row. The row, only one element should be there. That is a non-zero element. The all remaining elements are zeros. And the row sum should be the unity. What it means? So, for example, so it is the condition. So there is 1, 2, 3, 4, 5 rows are there. 5 rows are there, and 3 columns are there. The row one non-zero element is there. So the remaining elements are zero. The row sum should be unity. So then automatically, what is that element? That element should be the one, because of the row addition should be the unity, no? Row addition should be the unity. That row only one element is there. The row, all the sum of the row elements should be the unity. The row only one element is there. What? Absolutely, that element should be the unity. That element should be the unity. That means only one non-zero element is there in the row, and the element should be the unity. That's why, for example, this is 1 0 0 1 0 0 0 1 0 0 1 0 0 0 1. This is one. The column not defined. The row only specifies the row. Only one non-zero element is there. That element should be the unity. So it is the case of deterministic channel. So what it means in the deterministic channel, one element is there. That element should be the unity. That means output is determined as input. Okay. So that one element should be there in each row, and that is a unity. Now the P of y is equal to P of x into P of y by x. This is the output. Okay, output of the channel. So then, if the matrix multiplication is there, the first input matrix should be how many column elements are there? 1, 2, 3, 4, 5 column elements there. That's why absolutely there are 5 inputs in the channel. That is x1, x2, x3, x4, and x5. Okay, so row x1, x2, x3, x4 row matrix multiplied with column. That is 1, 1, 0, 0, 1. Okay, that is P of x is equal x1, x2, x3, x4, and x5. P of y by x is equal channel matrix. Okay, then if you give that relation y and x, that relation is P of y1 is equal to x1 plus x2, because of this is x1 and x2. Simply matrix multiplication is there. x1 plus x2. x3 is 0, x4 is 0. And the third one is x1 is 0, x2 is 0, x3, x4, x5 also 0. And the last one is X1 is 0, X2 is 0, X3 is 0, X4 is 0, X5 is there. So likewise, there is P of Y1 is equal to X1 plus X2, P of Y2 is equal to X3 plus X4, P of Y3 is equal to X5. P of Y1 is equal to X1 plus X2, P of Y2 is equal to X3 plus X4, P of Y3 is equal to X5. That is Y1, Y2, Y3 is there. Inputs are X1, X2, X3, and X4, and X5. So output is Y1, Y2, and Y3. So that's why can relate input to output, input to output. That is channel diagram. The channel diagram says Y1 is equal to X1 plus X2. No, this is the Y1. The connection to X1 and connection to X2. What is the magnitude? It should be the unity. Should be the unity. Y1 is equal to X1 plus X2. X1 plus X2. What is the Y2? Y2 is equal to X3 plus X4. X3 plus X4. And Y3 is equal to X5. Y3 is equal to X5. So this is the channel diagram. This is the channel diagram. Okay. So likewise, you can see that two types of channels today. One is the channel is noiseless channel, lossless channel, and another one is deterministic channel. So lossless channel is there is no loss in the path of the channel, and as it is, whatever the input is given, the same output is taken place. And deterministic channel, the output should be determined by the input only. So that's why there are today we discuss the two channels. One is the channel is lossless channel. The channel matrix should be one non-zero element in each column. The remaining all elements are zeros. One non-zero element in each column. The remaining elements are zeros. The row of the matrix should be the unity. Row of the matrix should be the unity. Like in the deterministic channel, one non-zero element in each row, one non-zero element in each row, and the row sum should be the unity. Row sum should be the unity. In general, the deterministic channel have one element in the row. That element should be the unity. One. That element is one. Okay. So it is the case of lossless channel and deterministic channel. Okay. Student, please be practice this and verify the textbook. In the next class, go for remaining two channels. The third channel is noiseless channel, and fourth one is binary symmetric channel. Those two channels are very important in the communications. So noiseless channel is the channel have the properties of lossless and deterministic. Both the properties, lossless and deterministic. So the noiseless channel have the channel matrix should be obeys the lossless channel property and deterministic property. That is the noiseless channel. Noiseless channel. Okay, these two properties are obeys. That is noiseless channel. And binary symmetric channel is those are two inputs and two outputs only. Two inputs and two outputs only. So in the next class, go for those two channels. So go through the textbook and prepare your own notes. Thank you for listening. Thank you, one and all.